Hi everyone and welcome back. Today we're going to do something really fun and really lazy. We're going to learn how to power up a computer that's been completely shut down, but here's the catch. We're going to do it remotely. Now you might be wondering, but Philippe, how the hell is that even possible? Well, the answer lies in a really cool technology known as Wake-on-LAN, or WAL for short. And it's not wool like the fabric, although I wouldn't be surprised if I accidentally said that before the end of the video. Wake-on-LAN operates at layer 2 of the Aussie model, also known as the data link layer of network communication, and enables us to start up a computer without needing to physically be there and press the power button. And there's a myriad of utilities for this, but my favorite one is that all of my servers are in the garage and it's really cold down there. To pull off this magic trick, we create what's called a magic packet. And this isn't just any packet. It's a specific series of bytes that include the MAC address of the computer that we want to wake up. And for those of you that don't know what a MAC address is, it's essentially just the identifier of a network card in a network. Once our magic packet is ready, we will wrap it up in an Ethernet frame and send it over the network to the broadcast address. Every device in that network segment is going to catch that packet, but only the host with the matching MAC address will react, and then subsequently signal up the motherboard to power up. You guys ready to give it a shot? No, but before we get too excited, let's make sure that we have everything that we need for this little project. And the things that we're going to need are a network card that supports Wake-on-LAN and the motherboard that is also Wake-on-LAN ready or WAL ready. And don't forget you need to enable this feature as well in the BIOS settings in your target host. But enough talk, let's crack on. Okay, now go to the Python website, download their latest release and install it on your platform of choice. In my case, it's going to be Windows. All right, and now for the fun part. I assume you already have your Python environment installed, or at least the software that you downloaded from the website. So let's get started. Now, the first thing that we want to do is we want to fire up your VS Code. Let's go into Open Folder, and I'm going to go in here into Networks, and let's just create a folder in here. We can call this Networks, or you can call it anything you want. Let's just select this folder. Awesome. And now in here, we can just go and create a file. And let's just call this wall.python. Okay, and we got our little Python environment here. We don't have an interpreter, but we got to select one here. You can pick one of these, but I prefer to just create a virtual environment. So let's just create one here, pick the first option, and enter the path into our Python installation. So we can just put this 312, this ought to do it. Now, the next thing that we need to do, we're going to need a library called Scapy, which is a phenomenal library for Python that allows you to do all sorts of cool things, network-related stuff, create packets, etc. So let's just go to terminal, new terminal, and let's do just a pip install Scapy. All right, it's installing. Cool, installed. So the first thing we want to do, let's do a couple of imports. So let's just do scapy.all and let's import, what do we want to import from Scapy? Send p, and then let's do another Scapy import. We're going to need layers L2, and we want to import our ether class. Now, the first thing we need to do, let's create a little function. This is going to be a very straightforward program or script, however you want to call it. So let's just call a send wall layer 2. It's going to take a parameter that's going to be a MAC address because we want to send this wall to a particular MAC address. So let's just leave this here and let's create a little function, a little main function as well. Little dunder here. And pass. Cool. All right. Let's just see if there's any problem with this. Seems to be fine. The very first thing we want to do is we want to clean up this MAC address because it's going to come divided with semicolons or dashes or whatever. And after that, let's convert from string to byte. The next thing we want to do is we want to basically create the payload. Oh, let me just be a little bit more tidy. Just put cleanup. So we want to create the payload. And our payload is going to consist of a hexadecimal value of FF. Okay, and this is 255. If you don't believe me, you can open up a little programmer's calculator and check it out for yourselves. But maybe hexadecimal FF, as you can see, is 255. And it's going to be basically the broadcast address. So we're going to want this 6 times. So we want 6 bytes essentially of FF, which is going to look something like this. Right? 1, 2, 3, 4, 5, 6. So that's 6 bytes of that. And then we want to add our little MAC address to it. And we're going to want the MAC address repeated 16 times. And I believe that the reason why people did it this way is to avoid like losses in signal or noise in signal or whatever, so that we don't wake up computers that we don't really want to wake up. So this has been specified like this. Okay, then after this, we're going to go and create our Ethernet frame. And our Ethernet frame is essentially going to be sent to the broadcast address. So the destination is going to be let's just put broadcast address. And we also want to bind our payload. And let's call this the magic packet. Okay, so this is the magic packet, which will consist of the frame with the payload information. And then finally, what we want to do is we just want to send the packet to the broadcast address. Okay? Or actually, we want to send the magic packet, because I don't want you guys to confuse this with the IP packet or anything, because this is purely in layer 2. So no IPs or anything like that. We're just strictly on MAC addresses. All right, cool. Now that we have the little stub or skeleton for our little function, let's go on. So here we want to MAC clean. So let's just follow what we just wrote. So clean up the MAC address and convert it from string to byte. So we're going to receive this in a really weird format. So we're going to, not a weird format, it's the correct format, but we want to clean it up. So we're going to do MAC address dot replace, and we want to replace a semicolon just with a space, and just for the sake of it as well, let's replace like if it has a dash with nothing. And then after this, let's just create a MAC byte. My typing is horrible. So bytes dot from hexadecimal, and we want MAC clean. Okay, very self-explanatory. So basically here we're going to clean it up, and then we're going to basically convert into a bytes literal. Okay, pass this as a value of bytes. Okay, let's just put a little print function here just to see if this is making sense. So let's put MAC clean. Actually, hold on. Let me just format this string. So let's just put something like MAC clean. And this is horrible typing. I'm sorry. I really apologize for this. I'm terrible typing when I know people are looking. And let's just do MAC byte. Okay, cool. Now we can go here and to remove the pass. And let's remove this pass here as well. And over here, we can just put, so send wall, and let's just make up a MAC address. So something like, now let's just see if this tokenizes it. Cool. Now we can remove this bit here because it doesn't matter anymore. Now let's go here, and then we want to create our payload. Okay, so our payload is going to be equal to our byte literal. And is it like this, or is it, I don't remember if it's like this. I think it's like this. Because I mean, if we look here, that's the kind of the format. So let's just assume that it's like that. If it doesn't work, we'll know what the problem is. So we want this times 6, like we just put it in here. So we want this repeated 6 times, so that we have 6 bytes of 255 in hexadecimal, which is FF. and then we want to append our MAC byte, and then we want to multiply this. We want this byte repeated 16 times in the frame. No point in printing the payload, just to put here magic packet, and this is going to be equal to our ether, and the destination is going to be the broadcast address. So it's going to be 1, 2, 3, 4, 5, 6. It's a very specific MAC address because it's the broadcast address. And when we send this packet, every single computer in the network is going to be receiving this. And then the next thing we want to do, we want to bind this to our payload. It's a bit confusing because it seems like we're dividing by the payload, but we really are not. This is an overloaded operator. So if we actually go into ether and we go into packet, I think it's packet, I believe, let me just see. Ether, packet, and if we have something like true, yeah, there we go. So we have this division operator here, essentially being overloaded. So it's not, what we're doing is not a division, it's just literally stacking things, because that's what we want to do. We want to be building our Ethernet frame. Okay, now send the packet, and it's going to be send P. Yeah, we just want to go here, we want to send the magic packet. Oh, and I forgot about this. So we need the interface as well. Okay, now this varies from operating system to operating system. I believe that in Linux you can just do ifconfig. I don't know what it is in the Mac, but here we can just go to a PowerShell. I have one here. PowerShell. And I think I can, yeah, there you go. Get net adapter. So you just do this, and you want to see what your interface is called. And in my case, it's called Ethernet, because that's what I'm using. So let's just put this in here. So just going through what we've done, we define a function that basically takes a MAC address. We convert that MAC address, we tokenize that MAC address to remove the colons in here, or the dashes, minuses, however this is called. Then we convert it into bytes, and then we construct the payload in here, which essentially, is made up of the hexadecimal value FF, or 255, and we want that 6 times plus the MAC address, which we converted to bytes, 16 times. Then we create the magic packet. We construct our Ethernet frame, and we send it to the broadcast address, which is this MAC address here. It's the broadcast address for every computer, and we literally just stack in this thing, this payload that we constructed on the top. And then we use this function here, part of Scapy, that essentially sends the magic packet through our interface here, our network card, or NIC, and this should switch on our computer. Right, let me just put the real MAC address in here. Now, I have a camera over there, and it's pointing to the host computer, and when I fire this program up, you guys should see the computer switch on. So let's just fire this up and see if it works. Now, 5, 4, 3, 2, 1. Woohoo! Switch it on. Awesome. It works. All right, now, this is one of the methods for switching it on, and it's purely at layer 2, and that's why we're using Scapy. But you don't need to use Scapy. You can also just use the vanilla, if you will, the basic Python version. Now the problem is we're going to have to use a socket, and a socket is a layer 3 element. Okay, so I'm going to show you how you can actually do that through layer 3. So let's just comment this function right here. And let's define, actually, you know what? Because everything is going to be the same up to here, let's just copy this, move it up here, and let's just layer 3. And it's going to take a MAC address, but and we're going to need a port as well. So let's just go here, and we can just copy this here. Too much copy paste. Let's put layer 3. All right, for this bit, we can just create a context. So socket.socket, and let's just do socket, and we want if.inac because we want this to be a IPv4, and we want socket dot, is this sock, Yeah, UDP. So we want a datagram. You know, just fire and forget. We don't need TCP for this. And let's just do this as sock. Little alias there. Okay, and this is essentially just opening and closing a socket. It's just a really convenient way of doing it in Python because Python is just awesome. And then all we do is sock.send. Is it send or send p actually? Send, is it send to? Send to, yeah. And send to, and what we want here, we want our magic, our payload. And we need a little tuple in here, which will be the broadcast and the port that we specified. Oh, and we forgot to do this here. Let's just put port in there. Oh, stupid. 9, not port. 9, because I'm calling the function, sorry. Send packet. That's it, or magic packet. All right, we're ready. So exactly all the same, just using a socket, so layer 3. 5, 4, 3, 2, 1. Is the camera recording? Yep. 5, 4, 3, 2, 1. What's this? An attempt was made to access a socket in a Did I? Maybe it's... Oh, okay, hold on. So we forgot to do one thing, which is we need to set permissions to allow the socket to be broadcasted. So we have to do sock.set stock option, and then we want to do socket.sol. So I'll explain in a bit, and it will make sense. Socket dot is it broadcast? Sorry, socket dot broadcast, and then 1. By default, this option here, I believe it's set to 0. So what's happening here is I want to say, hey, 1 means enable, so switch it on. Switch on the broadcast, so the broadcast at the socket layer. So allow me to send this packet to the broadcast area at the socket layer, okay? And I believe that's what this thing here is referring to. We could Google it, but let's just see if this works. If it doesn't, I'll pause the video, go Google it, and come back. All right, 5, 4, 3, 2, 1. Yes, Eureka! There you go. 2 methods to switch on your computer remotely, and you won't have to go to your cold basement or your cold garage, like in my case, or your cold attic to switch on servers if you have a network interface card that supports Wake-on-LAN. All right, everyone, I hope you had fun. I certainly had a lot of it. And if you want to see more of this type of content, let me know in the comments. And also, don't forget to subscribe and like this video because it really helps the channel to grow. For now, thank you for watching, and I will see you in the next video. Thanks.